started to do in 2004. I was with, extremely briefly with IBM, just a few months after IBM had acquired Rational Software, where I spent a good half of my professional career. And before that, I was at Alcatel doing telephone switches in France. Rational Software, where I stayed 17 years. I've been traveling the world. I started in France and then did some project in Switzerland and Germany, and then I moved to Sweden, and then I moved to California. And then I moved to Vancouver, supposedly for 3 weeks, but the 3 weeks became 3 months, and then another 3 months, and then another 3 months, and 5 years later, I was still stuck here. And in October '95, I told my kids, that's it, we're done, we're moving back to France. And my kids, I hadn't noticed, but they had become teenagers, and they said, no, sorry, Dad, we're staying here. You can go back to that stupid little country where you come from, but this is home. So we settled here. I'm a bit of a dilemma. I wanted to do a little game to illustrate a few concepts, but we are sort of a little bit tight. So first, I'm going to move the projector a little bit, and we're going to pretend that the hallway is part of our meeting room, and I will ask 3 of you to sit at the table. We don't need to see that much the screen. I'll be circulating around the tables. And then you 2 are going to turn around facing these 2, and then we're going to have another little group here. And I'm going to distribute you some stuff. But don't go immediately. Okay, let's do a little bit of preliminary work. So I'm going to switch a little bit the things. I'm going to do this little game first, and then we're going to look at how people have defined technical debt, and we're going to narrow it to, what I think is usable, relevant, and so on. We'll do this little game, and then we'll reflect on it for a little while, and we'll have a coffee break. I don't know if a coffee is more or less available continuously, or if there is specific times.
I think it's 10 something, but I can take
10 something, okay. Well, we'll try to adjust it. We'll do a little detour speaking about what is the value of software architecture, because then I can articulate a little bit better some of the ideas, the more recent ideas about technical debt. And then I'll tell you what various people around the world have done lately about this concept of technical debt to harness it and make it something that we can reason about and use and inspect, evaluate, prevent. And this should bring us to about around 12 o'clock. Any question? Switch off your cell phones and all that kind of great stuff, so we're not annoyed by too many things. And the compulsory acknowledgement, I have a little project with the Software Engineering Institute. I'm a visiting scientist, although I visited only once during the course of the project. I visit them by Skype every week. That's the extent. They're in Pittsburgh, which is not that easy to reach from Vancouver, so it's a bit of a pain, but Skype helps a lot. Okay, so let's do the little game first. Let me skip to the place where I have some explanation. By the way, we have, I don't know if you know it, we have Eugene Nisker, who is, one of the most active members of the junta, the little group of people who drive this strange organization called Agile Vancouver, whose official name is the Vancouver Agile Method Users Group, because the government didn't like Agile Vancouver when we wanted to register. And on the other hand, here we have the referee Gérard Metzaros from Calgary, who's visiting. Did you do a tutorial this afternoon or something like that, or yesterday?
Monday.
Oh, Monday, okay. I was not at the conference this year. I was at another conference in Seattle, so unfortunate. So, we're going to play a little game. It's one of the totally secondary byproduct of me working with some friends at the Software Engineering Institute. We noticed that some people were not quite aware or had strange notion about this concept of technical debt, especially people who are not directly developing software, people like product managers and business analysts. So we took a game that existed and we twisted it to illustrate a little bit some of the concept. So the game is played on a board like this, which I'm going to distribute a few. And each one of you will be represented by a little character. So we're using my kids' games. And we have a die. Many dice. One dice?
One dice, many die.
Many die. Oh, gee, I had it reversed. Okay, sorry.
One die, many
It's
dice.
one of those strange exceptions. I probably missed that class in English when I was a kid. So I don't know. I could never get it. There's something about mouse and mice also that. Like that. Anyhow, so the idea, this represents some kind of a development cycle. You start and you need to reach the end here by throwing the dice to tell you how many steps you progress. So every kid has played that, or at least in my age range, before we had electronic stuff. And you notice that there are little bridges here. So when you arrive here, you have a choice. You can take the bridge and go on, or you can continue on the main path. And the unfortunate thing is that every time you jump one of those little bridges, you take a bridge card, and whenever you throw the dice, later on, you have to subtract the number of bridges that you've crossed. So if you decide to take this bridge and you throw a 2, well, you can only progress by 1. And if you throw a 1, well, then you're stuck. Now, you can redeem yourself. You can skip a turn, give back the bridge card, and then you can progress again at your original speed. Looks simple enough. Then there's various things on the way. There's little tools. Initially, we had some ideas about different tools, but we made the game too complicated, so at some point in time, we had to simplify. So basically, you can land on a tool and you take a tool card, but you can actually go back. Let's say you have a 6, you can move forward 4 and back 2 in order to land on a tool and collect a tool card. So how do we decide who wins? Well, who wins is whoever reached the end. Oh no, I mean whoever has the most points. If you reach the end first, you collect 7 points, I think. We'll get to that slide. If you're second, you collect 5, and if you're third, you collect nothing, or something like that. And then you add the number of points you have. So, shall we give it a try? So there's rules there. The goal of the game is to accumulate the most points. There's some points for getting first. You have 7, 3, 1, and then 0 if you are 4 in that game. And then you add all your tool points, and they're all the same, the tool points. So you can go back and forth if you want. You don't have to rush to the end. If you're well ahead of the competition, you can take some time to collect more tool points. It's up to you. You can build your own strategy. I've changed recently this rule just to make the game simple. We don't want to spend a whole hour on that. So what I suggest, let's all get organized. 3 is a good number, 2 is fine, 4 is a bit too much. But let's open the door and let's use the table that it's in the lobby for 3 of you. So there are cards in the envelope, and I'll give you a little set of people and a die.
Do we have chairs out here, or do we take them over?
We're missing somebody?
No, they brought 2 more chairs.
Okay. If you want to unpack, you could put your chair here.
I'm okay.
You
Thank
okay?
you.
Okay. Okay, so What happened?
It's better not to play soccer.
Hmm?
It's better not to play soccer.
It's better not to take shortcuts. Do you all agree with that?
No. It's better to take shortcuts towards the end.
It's better to take shortcuts
Who
in the
took
short term.
shortcuts and won? You
She
took
did.
shortcuts. So okay, so I think you voted out there. Yeah.
Well, but it doesn't count second round. Second round, we dismiss all our points, right?
Yeah.
We keep our shortcuts, but
You
we
keep
also
the
have-
shortcuts. Yeah, well, no, the points are accumulated, but okay, it's done in the first round. But are all the shortcuts identical?
No.
Oh, hell no.
Okay, for instance, there was this, if you take this shortcut right at the start, well, basically you have to drag it all around. So now there's probably about 5 die throw for which you withdraw 1. But look, if you are here and you have no shortcut, maybe it's even valid to take 2 shortcuts in a row. You draw a 6, you do 1, 2, 3, 4, 5, 6, you're almost at the end. You have accumulated 2 shortcuts, but now whatever you throw, unless it's a 1 or a 2, you win. So all the shortcuts are not the same. So I agree with you, if you took the very first one, then it's pretty much dragging you all around. Has anybody redeemed a bridge by skipping a turn? Okay. Did you wait a few dice throws to do that, or did you do it immediately?
I didn't know.
Immediately, okay.
Because I took the exact same example that you showed. the
Oh,
two,
so you
and then I did the
that
next
turn.
round.
The,
No,
and
the,
the
very,
last
the very
ones-
last set.
Yeah.
The very last 2 bridges.
Yeah?
Then the next round, the first move, I redeemed one.
Okay. Well, if you were already here, probably it was not that valuable. Unless you knew already that you had to keep your bridge for the second release, but which was the little wild card I played. So, what else did you learn out of that?
Well, I think what happened was because I took a shortcut early on,
Yeah.
which put me ahead of the pack, and then everyone's concerned I would gain the market leader positions. And when they saw me there, they decided to risk it. Right.
Ah,
So up to that point, I was the only person in the game who'd accumulated some technical debt.
yeah.
The other guys would be like, well, you know, if he gets there first in the market, we're going to lose out in like 7 points. So they
Mhm.
pushed it, and by sheer chance, I made it to the end, and that didn't pay off.
Yeah. Any other?
In our game, no one was using bridges until and we're all fairly close, and then Carmen had decided to take a shortcut right near the end and sprint for the finish. And so the rest of us, we also on the next round went across the shortcut to try and keep up. But it was too late. She'd broken away from the pack, and we couldn't close the gap.
Yeah. So in general, but again, because it's a dice and you can be lucky or unlucky. In general, it's better to take shortcuts only towards the end if you are in a position of finishing. If you were to take shortcuts at the beginning, it's probably best to immediately repay it. Okay? So you do a 5, you go here, and you repay it. It's better than doing this and not repaying it. So it took us quite a long time to play to the position of the bridge to avoid people gaming the thing, because initially when we created the game, there was some obvious strategy. It was all of that or all of that. So it's now, I think we've got it to the point where it's sort of not too obvious. Anyhow, there's all kind of additional rules you can have. I have somewhere the original set of rules where the various tool things had different values and roles, and you could redeem them for a free turn, but it started to be far too complicated, so we would spend 15 minutes explaining all the rules of the game, but I think it's good enough like that. Okay, so since it's not coffee break time, let's go into some explanation about technical debt. So going backwards there. By the way, the slides are on my website. I'll show you the URL at the end. It's philippe.kruchten.com/talks, and it's the first one on the list. So, this concept of technical debt.
Another question for you.
Yeah.
Is the game available?
Oh yeah, it's available for you to download.
Is this
The little.
property of SCI or?
No, it's Creative Commons.
Okay.
Creative meaning you can use it. You have to sort of remind people where you got it from us, but you can evolve it if you want. You can change it. You can define your own rules, and so that would be. I may have a few. Oh no, I didn't bring. I had some little reminders. Okay, I'll give you the URL. It's on. It must be on one of the slides. It's not on this slide. Okay, sorry, I thought I had it on a slide. I'll give it to you at the break. So now you can download it. The game comes with little markers. I just replaced them with these little wooden characters, but it's nothing special. So anyhow, the concept was introduced by Ward Cunningham a long time ago, and a few people used it. Some people got the wrong message about the metaphor. It didn't make much noise for quite a few years in the mid-90s, and then suddenly a lot of people started to use this concept because they felt that it conveyed the right message. It represented very well what they were living in their organization. So the thing suddenly exploded around 2005. Lots of blog posting about technical debt. But actually, they mostly repeated the same thing. When we look at them, and Erin Lim has looked at probably 150 of them and analyzed exactly what they said about the same thing. And they more or less all refer to the same 2 or 3 sources. Now, people who are just beginners, the undergrads I have at UBC, they have no good feel for technical debt. You start feeling it really acutely when you've been in a software project that has lived a few years and accumulated 500,000 lines of code, and then there are these releases and you feel that it's harder and harder to bring new stuff. So actually I was yesterday with that gentleman, that's Ward Cunningham. He lives in Portland, and we were together at a conference in Seattle, and he looks exactly like that right now, so this is not a picture of him in 1992. Have you heard of him before?
Yeah.
You know what he's famous for?
Wiki page.
Yeah, he's the guy who created the wiki. So, somewhere, I think it was at the Hyatt, there was a conference called UPSLA in 1992. I was there, although I didn't attend his presentation. I was attending another presentation in another room. He made a little presentation describing what he was living in a large project. And he wrote in the paper that accompanied this presentation that shipping first-time code is like going into debt. A little debt speeds development as long as it's paid back promptly with a rewrite. The word refactoring hadn't been invented yet, we're speaking about 1992. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. Entire engineering organization can be brought to a standstill under the debt load of an unconsolidated implementation, object-oriented or otherwise. Well, that's, remember he was speaking at UPSLA, so he had to drop the whole word there. So, quite a few years later, Steve McConnell, with whom I also was yesterday in Seattle, because he's the guy who invited me, looked at technical debt and said, well, you know, not all technical debt look alike. There are two main big categories of technical debt, and in these two categories we can even make some subcategories. So we had a sort of taxonomy of technical debt. So there's technical debt that is unintentional. You know, you didn't want to do it. You didn't say, oh, today I'm going to introduce a little bit of technical debt, or I'm going to borrow some technical stuff. It's unintentional, it's non-strategic, you just, you know, do it. It's poor little design decision shortcuts, you know, gee, it's 5 o'clock, I need to collect the kids at the kindergarten, let me do something, and you even put a comment, you know, to be fixed later, and then you forget about it. But you notice that there's also a totally different kind of technical debt which may have the same consequences. We are at a crossroad. We can do the right thing with the right implementation, but it will take us another 2 weeks, or we can do this way in order just to get to the release, and then once we have the release, if everything works fine, then we're going to do the right thing. So you might say, well, you know, this data, they should be in a database. The right thing to do would be to pick MySQL and build a few tables, but we don't have time anyhow with this very first release. We have very little of this data. Let's just put it in a flat file, and then we'll put the database in the week after next. But then you just barely make it with this release, and then, you know, people are happy, and there's salespeople say, oh, and we have this huge prospect coming, and they'd like to have this, but they want that feature. Well, and then you say, well, sorry, we don't have time to work for them now. We want to put the database thing. Forget the database thing. Just add me that other thing, you know. And so you put more data in the flat file, and you deliver that extra, you know, 1.1 release, and everybody's happy. And then you say, now I can do the MySQL thing, and you get the story. Some other thing happens that prevents, and you know, you're 7 months later, and your flat file has grown to something absolutely ugly. You go on vacation for 3 weeks. There's some intern from SFU that comes and hacks the flat file, and then everything crashes, and nobody understands what's the structure of the data in the flat file, and you come back and say, oh, I knew it, we had to put all that in the database right from the start. And so things pile up. So it may be intentional and strategic. You may have a point where you sort of say, I know this is not the right thing, but in order to achieve this objective, let's do this suboptimal thing. And usually you say, and we'll do the right thing later. So can you repay it off quickly, you know, with an immediate refactoring, or do you live with it and start piling up more design decisions on top of it?
When you say suboptimal, you mean technically suboptimal?
Technically suboptimal. It's probably from a business perspective quite optimal. So Martin Fowler, for those of you who were at Agile Vancouver 2 years ago, he came up with a slightly different taxonomy. You know, he said, you know, I can do quadrant 2 like all these marketing people. So he had quadrants where he had reckless and prudent and deliberate and inadvertent. So there is deliberate and reckless technical debt. You know, we don't have time for design, let's just roll up our sleeve and get that code working. You know, we'll think about what's the right design later on. There is deliberate and prudent. We must ship now and deal with the consequence of not having done the right thing later. That is, we do value the proper design and coding standards and all that kind of thing, but we'll do that later. It is prudent. Maybe it's a matter of survival. Maybe it's very, very important to meet certain deadlines. The reckless and inadvertent, this is, you know, morons. People who are clueless. They run into technical debt, but they don't even know why and how. You know, there was things they didn't hear about. Now, there is the prudent and inadvertent, and this puzzled me for a while, but then I realized that I had done that several times in my career. it's prudent. That is, you're making the right choice, but you didn't know that it was technical debt. It's only later that this right choice at a point in time has become technical debt. Why? Because the context has changed. So let me give you one of the earliest technical debt that I encountered when I was at Alcatel. In the late 70s, beginning of the 80s, memory, and especially PROMs, programmable memories that we would put on boards, interface boards, well, we were limited to something like 8 kilobytes. So you finish your compile and you have all the functionality tested, but it's 8 kilobytes and 300 bytes too big. So now you're looking at the code and you start doing all kinds of things and you see little fragments of code and you look at the generated code and you put some kind of form of go to. You're damaging your code in order to get this down to 8 kilobytes, and then victory, we have 8 kilobytes, and on things goes to final testing and shipping, manufacturing and all that. And then months later, when you're working on the following release, the hardware guys tell you, you know what, the 16 kilobyte version is now ready. And then you have people say, well, why is the code that ugly? We have plenty of space. So now you have accumulated some technical debt, but it's not, you did the right thing at that point in time. So other example of the prudent inadvertent is you develop a piece of software with a certain purpose, and then because your company is acquired by another company, or because the market changes, the software starts to evolve in another direction than the one that it was originally intended for. You develop something where the most simultaneous users you could imagine originally was about 5 or 10, and now because you're successful, people want to use it in a context where they have 300 simultaneous users. So some of your original design decisions, which were quite wise for the 5 to 10, now start to look, gee, why didn't we do this? But it's so another slightly different view. An example of choices, hard choices that you have to make is, let's say you want to develop some application. Then maybe you want to have a lot of capabilities initially in order to look good, attract a market, understand what that market is, segment that market. So maybe you want a lot of capabilities without necessarily building a very, very heavy infrastructure upfront. But the other approach would be, we think we know that there is a market there, and it would be dangerous to have too many capabilities and then not be able to deliver a good service. So we want to first build a solid infrastructure and then gradually accumulate some more capabilities. Depending on all kinds of things about the market, maybe you develop the fantastic infrastructure, but at this point in time, before we have enough capabilities, some competitor is actually eating your market by having a lot of capabilities. Or you cannot deliver this infrastructure fast enough, so you have a nice burgeoning market, and then they got very, very disappointed, and they vote with their feet, going away because your infrastructure is not there. So there's very, very often this kind of tensions, and we'll see how to address them later on. Another person who wrote about technical debt, he actually wrote a whole book about technical debt, is Chris Sterling, who was also speaking here maybe 3 years ago. He's from somewhere near Seattle too. I didn't like much a large segment of his book. I think he's making the concept of technical debt so wide and encompassing that it's becoming a bit vague, but he had some very good definition. Technical debt are the issues found in the code that will affect future development, but not those dealing with feature completeness. This is important. Technical debt is not bugs. The bugs, they are visible outside. They affect your market. Technical debt, that's something different. it may be bad quality, bad design decisions and things like that, but they're sort of hidden. So having some defects that affect, the functionality or some other entities of your code and technical debt are not quite the same thing. Now, maybe the technical debt will lead to have more defects that are visible later on because you've made things too complicated and your developers do not quite understand what's there, but it's not quite the same thing, and his definition acknowledges that.
Can you use
Yeah.
Can you use the number of defects as a metric for the technical debt?
Not quite sure. We'll see that a little bit later. I think they need to be tracked differently and labeled differently. Now, when it comes to repaying technical debt or fixing a defect, it's the same kind of thing. You're going to do things and change the code and make it nicer and things like that.
Often when you're in a hurry to fix a bug, you're increasing technical debt.
If you're in a hurry, and
If you're rushing to fix a bug,
you may actually
you
increase
actually
technical
often
debt.
increase the technical
Yeah,
debt. When
especially
they promise to fix it properly after,
Yeah,
the next
if you do
release.
the ugly fix.
yeah.
Especially, I described to you a concept which is multiple component defects, that are defects which affect a large amount of components. Those very often, when they're done in a rush, they increase technical debt. Steve McConnell keeps revising his very nice blog post or technical note on the construct side about technical debt. And that's the definition he ended up with more recently. I grabbed this one just a few weeks ago. He has a nice webinar that you can attend on technical debt. It's about 45 minutes. So it's a design or construction approach that is expedient, allows you to speed up things in the short term, but that creates a technical context in which the same work will cost more to do later than it would cost to do now. So he's sort of exploiting the metaphor, debt meaning dollar, and he links that to cost. So you put yourself in a context where actually from that point on, the same work will cost more than if you had not done that before. So it looks like it's, speaks in terms a little bit of investment too. If I invest more upfront, then I have something relatively cheap to evolve. If I don't invest upfront, then it will be more expensive later on. But I have a choice. Pretty much like you could redeem the bridge in the game. You can say, let's repay the technical debt. Let's stop development and let's fix that. Although, again, is it a defect? Well, it's bad intrinsic quality. Other people have jumped more eagerly on the money metaphor. And the people at the Kotter Consortium, in particular Israel Gat, he wants to speak of technical debt purely in monetary terms. So basically, your technical debt, it's an amount of money that you owe, and he's going to express it in dollars. It's how much you need to spend today if you were to bring your system back to some ideal state. So the way he does that, he says, okay, I'm going to inspect your code, and there's this ugliness that's spread all around, little code clones and badly named variables and strange nested loop with some strange escapes, and so in order to fix all that, that much person days, and or you don't have tests for and regression tests and unit tests for all this part of your code. That's bad, Probably would take 300 person days to add all these tests. Your design, you took some shortcut there, this should not be in a flat file, you already have a database, make it some table in the database. This should not be just as text there, you should use XML and some XML parser to do that. So, okay, that's 700 person days to fix all that. By the way, the thing is badly, barely documented, so probably you're missing some. And you add that up and you load that with some cost per person days, and maybe you can say, well, some of them are local here in Vancouver, some are in Shanghai or Kiev or Buenos Aires, but you end up with some cost. And basically what Israel says is that's your technical debt. Your project, which has costed you $1 million so far, is actually in debt of $577,000. And by the way, you know, with my friends, the consultant, we're going to fix it. This is the order form, please sign here. I have reservation. When I saw his presentation, I say, oh, wow, that's, you know, exploiting the metaphor nicely. But after that, I had some concern. First, why do I want to bring the project to this ideal state? And what is this ideal state? If tomorrow you find another code smell, that means that this number is wrong. Actually, you can add some more. And you have this nice little static checker that finds all kind of other thing, then this number is some more.
And the
Why
closer
would
you go
I-
ideal, the more cost
Yeah.
you have to pay to the
Exactly.
next step.
And maybe I don't need to redo all that design. Maybe there's only one tiny thing that will give me quite some leg up for my next release, and I need to focus on that. And maybe I can not have unit tests for all that thing because we never touch it. Okay? And it's low-level stuff, and maybe I should focus on doing unit tests here because this is something that we're going to evolve. So maybe this number doesn't mean much.
Or it
First,
may.
because it's not an upper bound, it can increase forever, okay? And because maybe I should focus on a very, very small subset of it. So we need to apply more brain cell. We cannot just look at this kind of collection of what's missing relative to the ideal state. Yes?
But you can still have some meaning in it, because you may not want to go to ideal state,
Yeah.
but you want to assess where you are. It's not necessarily that you have to repay all the 577,000.
Absolutely. We'll
But
come
you
to
have
that.
to, yeah.
Yeah, absolutely. So basically the process by which you identify that is useful, providing you give some details so that you can actually pick and choose and trace that to what it is that we want to do from today. Where are we going? So you can actually select what you may want to fix.
I think it's
Yeah.
important to acknowledge that different debts have different interest rates.
Yeah.
Most of us go through most of our adult lives with a mortgage, a
Yeah.
rather large mortgage, but with a relatively low interest rate. But our credit card debt at 5 times the rate, we definitely don't want to have any of that kind of debt, whereas having a mortgage is perfectly fine, and we're comfortable with it. So I think the
it's a
metaphor is good,
metaphor,
but we have
but
to
it
think about how to
breaks.
apply it.
It breaks, and it breaks in particular in another way. Unless you go in hiding, change name, and emigrate to Guatemala, your mortgage debt, you cannot, leave it behind you. But in software, we can. We can sort of say, oh, let's not evolve this thing.
I think there's
let's
a lot
do
of
something
people in
else.
the US who would disagree with that statement.
Yeah,
And I know people who've walked away from their houses.
yeah. It's harder to do in Canada. I
It's
think.
harder than that.
You're still caught up with them though.
Question.
Yes.
To put this into perspective, you have to compare this depth with good points, right? Like in your
Yeah.
game. So we have to have several same assessment for, let's say, release, right in time. So
Yeah.
how much benefit are we getting from releasing just in time?
Well, we look in the we poke our nose in the concept of value and cost.
Uh-huh.
And then we'll revisit technical debt once we have dug into value and cost. I'm just saying, this looks appealing, this approach, but it don't take it to face value. We haven't found the absolute unit of measure for technical debt. This number is some nice indication. It may be an upper bound, and it may be itself not quite an upper bound because I can make it go higher. It all depends on what this is, this ideal state. There's a lot of subjectivity in this number. But it's big flashy numbers. It's like the chaos report. Oh, 50% of project fails, you know. Big impressive number to impress some people that may not have a lot of reflection. So they get some traction from that, but I would use it with a grain of salt. However, Israel, in the same presentation, he has a nice little diagram that reflects pretty well what's happening in a lot of projects. There is pressure. You take some technical debt to relieve temporarily some of that pressure. You fail to pay back the technical debt accrues. You reduce, therefore, your team productivity or velocity, and unfortunately the pressure is not relieved. And then you take more technical debt. So there's a sort of vicious cycle there. If you are in circumstances where you're not quite aware that you're taking technical debt, or you're not in a position to repay it. And if you Google technical debt, you'll find actually quite a lot of variation on the theme. Jim Highsmith, who used to be with the Qatar Consortium and was presenting with Israel, has now moved to ThoughtWorks, so he's now a colleague of Martin Fowler. But he presents that technical debt this way. So there's the cost of change and the time, and there is the optimal cost of change, but there is the actual cost of change that grows higher, and the difference here is technical debt. So Jim says, you know, there's only 3 strategies there. You know, if you do nothing about technical debt, if you just let it accumulate and, you know, acknowledge this as some kind of a fact of life, it gets worse, and it gets to the point where it really, as Ward Cunningham suspected, brings the whole engineering education, engineering organization to a standstill. You could just decide to throw away the product and start from scratch, say, oh, it's too ugly now, let's just redo it. But that has a high risk. It's very appealing for some technical people. Oh, we'll rebuild it now using the best programming languages and the best technology, and we'll have a lot of fun writing brand new code with all the right good tools for the next year and a half. And I've seen 2 companies die. There was a very nice Swedish company that we worked with called Intentia. They had this ERP system built on AS400, and they had 6 million lines of code in some ugly language that I had never heard of before. And they decided that they would replace the whole thing by rewriting everything in Java, and it would take them just a year, and the salespeople and the customer support people will hold the customer's breath for a year. A year later, they had not reached the replacement point, and a year and a half later, their customers started to go away and go to BAN and SAP and all this kind of. And 2 years later, they were dead. The company went belly up because they had misestimated the time it would take them to just get back to the same point, but also the fact that they were unable to do more than a few small bug fixes for the 2 years.
I was just curious, did the original product continue to evolve while they were trying to...
Just little bug fixes,
Okay.
no new feature, nothing.
Mm.
They were also squeezed on that strange platform, the IBM AS400.
I've seen the same thing happen
Yeah.
on several occasions, several companies that
And it was
been asked
nice
to help
people
have gone
with...
bankrupt because of that exact same thing. There's actually a name for it.
Yeah,
It's called second system syndrome.
yeah.
Because the second time around, you know all the things that you would have liked to have done the first time, and it gets totally over-engineered and takes way longer to build, and usually is technically impractical.
So Rational Software 1991, we had to get out of our first system because our initial market, which was defense and aerospace, had shrunk considerably. We were under attack also of new open source stuff, and we almost died going to the second generation, the tools that some of you may know, like rational rows and all that kind of thing. And I remember the months where we couldn't make payroll and the months where we had to lay off, 37 people, painful days. We had a we were that close from bankruptcy. Bank said, we won't give you $1 more million, sorry. So we were almost hit by the second system thing. So some of us, the more senior people, we decided to take a pay cut for 2 or 3 months. We got a big pile of stock options in exchange for a pay cut. They were very valuable 8 years later. I bought a house in Vancouver with these stock options. So, the second system syndrome, there's quite a few stories like that.
Excuse me?
Oh, yeah.
Does it always fail?
No, it
Because,
doesn't always fail.
You know, from what you said, I'm under the impression that it never works. We should never do this, and there is you gave us some examples about how it fails, but you didn't give any
Well, we
about
survived.
successful
We
companies.
survived. I'm just saying we were that close from failing in the second case, but we
Yeah,
survived.
I just wonder
And we
what's the-
thrived actually,
And
What's the
we went to
percentage of
Oh, I don't
companies
know. I
that
haven't done statistics. I'm not an economist. I don't think we have statistics for two things because first, failures are extremely rarely reported unless they go to, companies being bankrupt. But I don't think that there are people who are actually counting this. In our industry, we're so focused on successes and nice stories, we tend to completely ignore and dismiss any failure, and there's very little, or we hide them. Sometimes there are failures that are disguised into successes, and we do not analyze. Maybe the people who are involved, they do some analysis, but these things are completely undercover. No, it's feasible. You just have to realize that first, don't do it just to please the technical people, and maybe you want to do it incrementally. In the first case that I described, they didn't try to keep any line of code. They just redesigned the whole thing. And I'm going to give you another example of a system that failed later on after the break, of a system that failed and had to be restarted, and it ended up being a success the second time. But it was a big organization with a lot of money in its pocket, so they didn't go bankrupt. They just had to wait more and more years to have a system.
But you heard about WestJet's
No?
system. They had their own home-built reservation system, and then they engaged a company to replace it. And after 2 years or something, and $50 million, they trashed that, and then they did another attempt. I'm not sure if that was the third or the fourth attempt that actually worked. Now they're on Sabre. But there was at least one, if not 2 systems in between that never got delivered.
And Sabre, this is one of the longest systems.
That is a legacy system.
If you speak about legacy, that's legacy, so
It's American
it's
Airlines.
as old as me. An example of technical debt, there's this nice Italian company who developed some 16 years ago this nice little product. And they were very successful. So they had another release the following year, and there's another release the following year. And they have a relatively small, very dedicated team, very little turnover. They're in some strange city where I thought they were doing only marble, but they do also software. And Marina di Carrara. And they grew and they grew and they grew, and they had different lines of product. Their software is not visible, it's embedded in another device and it's used on boats. And the software grew and grew and grew and reached something like about 4 million lines of code. And then they were bought by a US company who was very impressed by the products. And the US company wanted a few adjustments and features to better fit the US market. And in particular, there was just that one feature, we must have this one, and probably you can do it in a few weeks to their new acquisition, this Italian company. And the Italian people said, this one, that's a tough one. It'll take us a good 6 months. The managers of the company in Denver said, there's something fishy there. This can't be right, And I'm even quoting you, one of the manager of the company who said, I described the feature to my son. He has a son who's in computer science, a student in computer science, and my son told me, Dad, I could do that, almost overnight. You Italian people, they're ripping you off, Well, that was a project that has an enormous amount of technical debt. And just to add that simple feature, the problem was not coding the feature, but integrating it into this absolutely awful mass of software where they had piled up technical debt and technical debt and technical debt. So I went to see the Italian company and we discussed about various things. And I presented the concept of technical debt and they had this ha-ha moment. Wow, that's how it's called in English. That's what we've been suffering here for the last 10 years. Every release we tell our management, give us a break, we need to clean up the code and we need to change this, and they always say, no, we have another release, we have another product, we're adding a 6th product line, and we keep churning the things and cutting and things. It's awful, Philippe. I don't even want to show you our code, So that's a case where they still don't know if they want to scrap the whole thing or gradually redo it.
Did they buy it in the end, or did they
No,
cancel
it was after the buy. It was after the buy. No, they're part of that big American
It
company.
didn't do their due
Because they
diligence.
unload the debt to other company.
That's another thing. Unload the debt to somebody else. Oh yeah, let's hire 60 people in Shanghai and we
Yeah,
ship
right.
them the code and then we say, oh, this is ugly.
That's what we said.
Okay, let's have a coffee break. Okay? If there is coffee, I don't know. That's the URL for the game. So it's sci.cmu.edu/architecture/tools/hard choices with an S. If you are a fan of Q codes, that's the Q code for it. And that's the licensing blurb, Creative Commons, with attribution, no commercial use. So don't start doing little kits that you sell over the net. Otherwise, I'll be on you. With my lawyer. Just kidding. Actually, the SCI might be a much harder ball to play with than the SCI. It's basically the US Department of Defense. So I just received the paperwork for the renewal of my contract as a visiting scientist, and it's something like 16 pages long in very small print. Sign here and sign here again and sign here again.
And how much did your lawyer charge you to
I
interpret
don't
it?
know, I don't have a lawyer, I don't understand half of it, I just sign, okay, just get your stuff.
You realize you just signed away the right to your firstborn and your house.
Yeah, there was, in the first one, I negotiated something. They wanted me to take some liability insurance on all kind of things. I'm sorry, I'm not even stepping foot on your premises. I'm not like the contractor that fixes your roof or your electrical thing or your IT. So we're just speaking on Skype 2 or 3 times a week. That's all. So give me a break with millions of dollars of liability insurance. Anyhow, let's go back to the slide. Okay, that was the game. What is the value of software architecture? Now this may look like a day 2 and has nothing to do with technical debt. Actually, I think it has. One of the difficulties that we techies have is articulating clearly, first for ourselves and then for our stakeholders, managers and other people, what is the value of design and what is the value of architecture. And sometimes also we don't value it ourselves that much, so it's hard to express the value. And the discussion we had during the break, where you say, well, I can see the technical debt, but they don't let me. Who is there? If you were able to articulate the value, not just for you and your team, but for the organization, of design, the intrinsic quality of your code, then they'll feel more concerned. If they say, oh, this technical debt thing or whatever you call it, this is your problem, it's because you're inefficient and bad people, and then we have this problem that you will not be able to do it. One of the things that I notice, which I find a bit unfortunate, is that in our software community, there's very often, not always, but very often some confusion about value and cost. When I speak about value, it's value to the business, it's value to the users, the customer, the public. Now it depends how this value is manifested. Depends pretty much on the context in which you evolve. If you are the IT department of an organization, you're not selling your software. If you are an independent software vendor and you're selling software licenses, the model is different. So if you're selling software, it's a little bit more obvious how to establish the value of what you develop. If it's software that is developed internally, if you have an open source model where actually you're only selling services, but you're not selling the software itself, the value is a little bit harder to articulate.
And a lot of organizations, even there, the value is stated quite explicitly, because someone has to make a business case for investing this much money in the system, and they have to talk in terms of how much value is being delivered to the organization. Usually in the form of reduced headcounts or higher, transaction volumes that existing workforce would be able to produce. So, in disciplined organizations, the value equation is just as obvious as it is in a product company. Although the projections, in theory at least, should be more accurate because you have more control over the environment.
Yeah. But when you express things in gain in productivity, not productivity of the software developer, but productivity of the organization,
yes,
we will have more the extrapolation and bridging the gap with the features of the software system that you're developing is sometimes a little bit hard to articulate. But okay, value, it's what's facing outside. Cost is the cost to design, develop, manufacture, deploy, maintain that software. So in software development, especially if you're developing pure software, not a software system that is some bugs and some hardware and some other stuff. If it's pure software, it's mostly paying salaries with some loaded cost to account for the rent and the electricity and your expensive laptop. Now, if you have a very simple system with a very stable architecture and you're only doing little pieces of software development, adding feature, the value and the cost of those features they may track statistically if we're speaking about very small things, and it may not be enormous value to distinguish, but when things are large, when they are relatively complex, when there's multiple integrated systems of systems, when the system is relatively new, you're going boldly where nobody has gone before, at least nobody in your organization, then maybe value and cost do not strictly align. There may be certain things that have a very at least perceived small value, but they have a high implementation cost, and vice versa. So it's useful to distinguish them. Now, architecture, software architecture, the bones, the skeleton of your system, it has very little external value. That's not what you sell. That's what we have to do in order to have a robust system that has all the right utilities, including performance, which is not a leading utility, but it's an important one. But it has very little external customer value. the features that we want or the services or the functionality, that has value. Maybe we cannot articulate the value of each one of them. There's a difficulty disentangling them. So when things start to be a little bit strange, I think, and some organizations have pushed it too much in one direction, if you do iteration planning and release planning based only on this visible customer value, if you are unable to articulate the value of architecture, you're going to focus on the feature, but maybe not so much on putting in place the right architecture. So that's a reason why, and I'll give you some extreme example of that later on. That's why very often architectural activities are not given enough attention. It's sometimes exacerbated by mottos from the agilistas about, oh, we don't want big upfront design, or you ain't gonna need it, or we'll refactor it later. Or people calling me Jeff Sutherland, we must deliver customer value right from the first iteration. That doesn't mean something that is usable by an end user necessarily. Jeff told me when I was having dinner with him in Denmark 2 years ago. But sometimes it's interpreted a little bit too literally. So that's one of the reasons why architecture is not receiving necessarily a lot of attention. Another thing which is hard is reasoning, except in very mature, rigorous organization like what Gerard described. It's sometimes very hard to reason in purely monetary terms. That is, there are things you want to do in your software system, and putting a dollar value on each one of them individually is hard. Maybe you can say, if we build the whole system, we'll have this increase in company productivity or sales, and we'll have this rough amount of value. But then, mapping that onto little individual things, features, services, functionality, use case, scenario, story card, that's pretty hard to do it in monetary terms. Similarly, when we look at cost, it's very hard to sort of say, oh, how much is it going to cost us to do this story card or this use case or this scenario? We don't work like that. We would say, well, at best we can do how many person days, or maybe sophisticated organization would go to function points and then translate that into person days, and now we have also story points. But how much is a story point in dollar? Do you know? Would you know? Well, maybe we can. 4.73. Good. Plus or minus something. So we have become relatively comfortable with some notion of points to judge the cost of developing certain things relatively. Okay? Because it's a relatively arbitrary unit of measure or point. But
technically it's relative effort.
Yeah.
Not cost.
Yeah, but we can translate from effort
Yeah.
to cost.
Yes.
It's not
Yeah,
too
we do
difficult
the
to-
math separately to get
we can
cost.
do exactly. So we have this notion of this proxy for cost that is a point. Okay, it's like a proxy because there's a relatively simple translation to the actual cost. Well, maybe we can do the same thing for value. So with some people, we started doing that at Rational Software, also evaluating the value of things using some system of points. So there's different tactics to do that. Dean Leffingwell describes some on his book on scaling agility. We would take some very representative feature that was not too big and say this is a 100, and then we would say, well, relative to this one, in terms of value for the outside world, this is a 10, and this is a 120, and this is a 50, and this is a 2. So then the little addition that was contributed by some people at the SEI, Rick Kazman in particular, it started to be very weird in the software development organization to have two different kind of points. We had points on the cost side, the effort, as Gerard says, and we had points on the value side. And then we actually increased the confusion. Sure, we had gone from dollar to points, but which points are we using when we do planning? So we decided to call the value side the utils. Not my idea, it's Rick Kazman's idea, but the name stuck among my friends and colleagues. So points, we know what we mean. You know, it can be story point, it can be what you do when you're doing playing poker, which is the new fancy name for wideband Delphi. But utils is on the value side, and the utils is done with the product manager, product owner, whoever represents the business analyst, and relatively independently from cost. Don't pollute your reasoning about the value by saying, oh, but this will be expensive to develop, therefore we should raise the value. No, they should be independent. And the evaluation of cost or effort done with the people who are best placed to evaluate how much it costs, which is not your business analyst and the salespeople and the customer, but the people doing the job. So, utils and value. Another thing which, this is this URL that I've looked at when looking at what is the value of architecture is that the Scrum Backlog 101 class, what you do in the first hour is looking at the green stuff. What are the features that we want to have? You know, to decompose them to some level of granularity so that there is some notion of doing things first and second and last. And we're going to use that to spread the development over multiple iteration or sprint as it's called. So there's a lot of things that I express in terms of the green stuff. And the green stuff is visible and will bring positive value, and it has some cost. But then, as I mentioned earlier, there is hidden stuff, stuff for which we do not see some obvious value. I call it the yellow matter there. The putting in place a database and JBoss and the server and the load balancing and the linkage with the authentication things, LDAP, and this is not visible, this is not what you're selling. It may be in support of what you're going to sell, maybe in support of the green stuff. So there's yellow stuff that will need to be done, not necessarily upfront, but needs to be identified, and some of the green stuff will depend on the yellow stuff. Sometimes a bit more complicated, some of the yellow stuff depends on other yellow stuff. So, it has a name, technical stories, as opposed to, something that relates to what a user would do. Then, you're going to plan your iteration doing some combination of yellow stuff and green stuff. We'll do a little bit of the yellow stuff, just enough to support some of the green stuff, and then in the next spring you're adding and refining the yellow stuff to support more green stuff, and so on. So it's not big upfront design. Let's do 6 iterations with only the yellow stuff, and then we'll come back down from the mountain with the perfect architecture to which all the features can be built in the last iteration. So I'm not advocating for some big upfront architecture only at the beginning, although I've seen it done in some various organizations. So, green stuff and yellow stuff. If you already have released stuff, there's probably also some pressure for you to fix whatever bugs, defects, imperfection have escaped, ended up in the hands of the customer. Not necessarily the stuff that you code as you were developing, through testing and other activities of quality assessment of your product. So there is the red stuff there. And then after having looked at two things, I was wondering, maybe there is something here that's technical debt. It's invisible and it has a negative value, but it's not a negative value that is exposed to the outside world. You know, as you were mentioning, it's only inside the development organization and on the technical side. Actually, the outside would say, hey, you did it to yourself. You know. So technical debt, it's in that quadrant, it's invisible, pretty much like architecture, and it has a negative value, but this negative value is not expressed necessarily in any form of dollars. So let's go back to how this relates to technical debt. Another way to look at technical debt can be, illustrated this way. Let's say you have this feature, it has a value of 12 utils. Doesn't really matter what a util is there. There's a value of 12 utils. And there are, when we look at it from a development perspective, there are 3 possible strategies. We could do it by developing this very interesting architectural feature here, and which has a development cost of 5 points, and then build it on top of it, and that would be 15, so a total of 20. Yeah, but this looks like expensive, so I think there's another strategy. We could reuse this stuff that we've done in this other project last year, and it will be cheaper because we can just do some tweaking to it, and on top of it, it's a little bit more complicated to implement, but the total cost is 19. Aha, says your business side of the company. That's cheaper, I like it, but it's still pretty expensive. Well, we could also just, forget all the niceties and just brute force the whole damn thing, and that's even cheaper. Oh, I love it. Let's do that. Actually, before we run into that, there's probably not only the only feature that you want. There's another one here that is has a value of 8 util. And if you were to implement it on top of that nice little architectural feature, it has a cost of 5. So the total of doing both, this one and this one is 25. But if we're only, taking that old piece of software from that old project from last year and tweaking it, this is more expensive. So this has a 27. And we could just independently, have this team brute force this one and this team brute force this one. 20. So here you start seeing the effect of doing the nice architectural stuff. It's cheaper. So when you have this complete picture, it starts to be obvious. If you want this and this, while doing the right architectural stuff is the obvious way to go, because this is globally much cheaper than doing the crude stuff or the not so quite nice stuff. Unfortunately, in reality, things happen this way. First, we want this one, and we'll say, you know what, the other one will do it later. So there is no incentive to do the proper architectural stuff. So basically, you're going to brute force the first one. And then you come with the second one and says, now that we are successful with our first release, let's do the second one. But now it's a little bit more expensive in total. You remember if we had done it, it would have been 25, but here now it's 30. Why? Because first we brute force it here, but we're introducing the right architectural element. This one is relatively cheap to implement on top of it, but we have to retrofit what we had done in the previous release onto the new one. That's +2 here is the interest we have to pay on our technical debt. We've taken some technical debt by doing this and not doing the right architectural stuff, and now we have this additional payment. So in total, it's more expensive. Now, from a technical perspective, you would say, well, this is stupid, we should have done this right up front. But maybe from a business perspective, maybe we're better doing this and being there on time on the market and satisfying this customer constraint and then paying the fee. The problem is if you're not doing this now, it's like not, redeeming your bridge on the little game. If you continue to brute force things will maybe not turn that right, and pretty rapidly. Actually, something that I don't know if I made a slide about that. I have the feeling now that a highly iterative project can run into technical debt much faster than other organizations if they're not very careful and it's not made visible.
So can I just say
Yep.
one thing? Since people like Ron Jeffries aren't here,
Yeah.
if you just go back to the one slide,
Yeah.
the argument that Ron would make
Mm-hmm.
is that given that you already have implemented the 12 equal feature for $18 on the left there,
Yeah.
the architectural feature A doesn't cost you $5 to build. And it doesn't cost you $2 to retrofit
Ah.
onto A. In fact, to do the refactoring and extract from the code you've already built for the 12 equal feature would probably cost you a couple of dollars. And the total cost would probably be 26 as opposed to the 25 if you did it the optimal way. And I would agree with him. The proviso is that it requires good technical skills to do this.
Mm-hmm.
It requires people who have experience doing refactoring and are used to doing sort of continuous refactoring as opposed to refactoring as in we're re-architecting this code in big steps, doing sort of small step refactoring. And that's a level of technical skill that takes a while to accumulate, and most organizations never
Mhm.
get there because they don't do enough refactoring. They don't do
So
frequently
what,
enough.
what you're saying is that part of this was already implemented here.
Yes.
Maybe not, and maybe it's not the case.
Well,
Maybe what you have to do, maybe what you've done here is pretty crude and there's nothing that can be reused there. So this is where you have to look at the specific circumstances.
Yeah, exactly. But
So what you describe
what you're
may be the
effectively doing
case.
is generalizing the code you've already built and separating it into the framework part and the concrete instance. So it's the Hungry base model where you're pulling functionality out of the concrete examples and pulling it into the reusable base. And all I'm saying is it's not quite as simple as, the same effort as it would have been before if you'd done it proactively.
But it can go the opposite way as well, introducing kind of the right quote-unquote architecture into existing code may be more difficult than introducing it from the very beginning. It may go this way as
Maybe,
well.
but typically it's not unless you waited too long and you built up too much technical debt along the way.
Which is often the case.
But this is why I say the difference is if you have the technical skills and the discipline to do continuous refactoring, then it looks more like what I described. If you don't have that discipline, then it looks more like what Philippe described.
There is another argument though, that the cost for organization may be lower down the road, not because it's easier to implement, but because the cost of a dollar is lower. For a small startup,
Yes.
every dollar costs more than for a much bigger organization.
Yes, and that's the whole Yagni argument is you don't want to waste money that you may not need to spend or spending it too early. The other thing there's a third dimension to this, which is the cost of doing it may be cheaper because doing speculative generality is more expensive than using concrete examples
Yes,
to
that's
drive
for
the
sure.
generality.
That's
And
for
that's
sure.
why the 5 actually becomes smaller, partly because you don't have to speculate nearly as much.
This argument, I'm more willing to take it than most of the thing is already there. It's just a matter of extracting it and repackaging it. Yes,
But there will
because you
always
have
be additional
complete
code.
examples. Now you're going to build just enough architectural stuff rather than
Exactly, yes.
I don't know how many 6 or 7 features will come, but just in case, I'm putting all that thing in place.
Yeah.
That I'm more willing to take.
And that's what people mean when they refer to emergent frameworks or emergent architectures, is putting just enough architecture in that the concrete examples that you have acquired thus far actually
So-
require.
That's the thing, which is in my experience and opinion, very difficult to achieve. And I hear a lot about the architecture will emerge gradually as a matter of refactoring. The organizations that are able to do that are pretty rare. I haven't seen that many.
Most
especially when they
organizations
tackle big things.
don't have enough technical skill and don't put enough of a premium on technical skill to get good in it off at that.
So I'm jumping on something to illustrate a little bit this discussion, but I'm glad you asked the question, we bring the point on. So this is a project, some organization, it's a worldwide organization, they are the result of two mergers, so they ended up with this very complicated system that doesn't integrate very well. They just build some crude bridges between their various systems to survive. So at some point in time, they decide to re-engineer the system completely. So the existing system is about 2 million lines of code. It's a combination of C, C++, COBOL, and Visual Basic. Nobody dies if their system fails, but they maybe millions and billions of dollars lost. So they put in place in one city, in one building, so ideal circumstances, not the distributed team, outsourcing, and things like that. A team that decided to embark on a combination of XP and Scrum with 1 week iteration. That was pretty bold. They have about 30 developers when they start. They then scale that up very rapidly to 50. And they do very, very rapid progress. First, they don't have to invent much of the requirements because they want to replace an existing system. They have direct access to some of the users that are actually in the same building. So they can speak to these users and they can run demos on the Wednesday afternoon to these users. So they do some very rapid progress. They have some good success. They demo things and it becomes rapidly what I've called a poster project for scalable agile development. And then after about 4.5 months, they start having difficulties. First, they have difficulty keeping with 1 week iteration. So they skip the demos and the people on the other floor say, oh, you didn't work this week? Well, it's not, we did a lot of work, but there's nothing else that we can show you. It's the same thing as last week. So the refactoring start taking much longer than 1 iteration. So they scratch the iteration. And also, they start noticing that what I call, they don't call it like that, the scrap and ratio, scrap and rework ratio increased dramatically. That is, in order to do further progress, it's not just little tweakings, and changing things. They start having to destroy a large number of lines of code that they have. Trying to do what Gérard was describing 3 minutes ago, but unfortunately it takes them, to almost, to redo completely the thing that they have. Whereas they were expecting to just continuously, bring next story card and continue to pile it up. So they get to the point where there's no externally visible progress. The iterations are now stretched to 3 weeks, which is due in part with the number of people that they have and the lack of a clear partitioning in chunks of code that is sufficiently autonomous. That is, many of the changes they have to do start rippling to all the code. And then, all kind of things happen at the social level. People point fingers at each other. Since 4/5 of them are not employees of that company, but just guns for hire, say, well, this is not the way to do Agile, and my Agile is more Agile than your Agile, and I'm not going to work in that company that decide to abandon Agile, and everybody knows that a good iteration is 2 weeks. So lots of slamming the doors and finger pointing, and the project comes to a complete halt. So they end up with a lot of code, about 400,000 lines of Java, and they have no architecture whatsoever. It's just lots of code that is intermingled, and at the surface it actually demos pretty well, but they come to the point where there's no obvious way forward. They had, in my opinion, naively assumed that an architecture would gradually emerge as a matter of weekly refactoring. but nobody was actually in charge of, putting some kind of intentionality, trying to actually direct an architecture to emerge. It doesn't emerge just by accident. So what they had was an enormous amount of technical debt. They have made all this scattered little decision by working in little groups of 5 or 6 in the various offices with no coordination across. And then when finally they're forced to do some coordination, it rips the whole thing. It's like trying to put a carpet in this room from below you with you still sitting and me still teaching. Okay, so that's how it felt when I went there, the first and the second time. They were trying to push an architecture from below. And the architectural issues that they had were not very simple. They were trying to achieve a very high availability, and by exploiting the fact that they had site in 3 different cities around the globe, and they had some telecommunication aspect and some replication of data aspect. So all the nice little GUI demos that they were doing for their local customer, yeah, that's nice, it's good code, no worries, don't throw away the screen, but how are you going to handle data and high availability and very accurate things and the conversion of the old data to the new data, and that they didn't put any attention to that because there was no story card on the board about that. So I don't know if somebody imagined that they would have a story card, for iteration 17, reliability or availability, or you do this one, So yeah, the dream, the ideal, something that some organization can do is having the architecture gradually emerge, pretty much the way Gérard described, but it's not going to happen just by accident.
The larger
Because
the organization, the more
They were
effort and the more
also a lot.
explicitly you have to do it. The utopian model of a small team, everyone's equal, everything operates by consensus. It's fine when everyone fits into
They're
a small
50.
room.
They were 50 when I went there.
But when you're a larger organization or larger code base, there are architects on the project. The difference is that architects actually do the coding and the refactoring to the
Yeah.
architecture as opposed to sitting in a room.
There was no
PowerPoint.
architect. It was actually a bad word in this organization.
that's
They wouldn't
part of the
say
problem.
architecture. Oh, no, we don't do big up from design here. So go away. Okay. So, yes, architecture could emerge out of refactorings, but it's not going to emerge by magic. Somebody has to play the role of architect, which is not sitting in a nicer office in another building, dreaming things and doing fancy UML diagrams, which means, developing code and doing, as Gérard expressed, doing the refactorings. I've lost my train of thought now, sorry. Okay. When people try to push the technical debt metaphor, there's some interesting discussion about what are the interests, what represent the interests, how do they manifest. The interests are a little bit harder to express because you have some either poor quality of the code or some poor design decision or architectural decision. The cost of doing new things is higher. Now, there is some interesting discussion as can that be detected by an increased velocity? Maybe, but since velocity is a relatively subjective, relative notion, very often the development organization, when we do estimation of what's ahead of us, when we do the estimates and the costing, we implicitly integrate already the fact that we have technical debt. That is, we do not do points, thinking that it's ideal because we know the code base that we have at any given point in time. So I wouldn't rely just on watching how velocity evolves over time to decide whether you have some technical debt or not. because your velocity may be nicely constant because you've already integrated in your head the fact that things are harder and harder. So that, I'm not sure. Yesterday, when I was, no, the day before yesterday in Seattle, there was a gentleman there who's it looks like a Scrum purist, who actually think that, no, in my team, people, when they estimate things, they estimate how it should be ideally, and then I see the velocity decrease. And we had an interesting discussion there. So this retrofitting, which is what I was trying to exemplify, and where Gérard pointed out that maybe it's not that costly if you're doing things wisely and can actually extract just what you want and generalize that into the architectural feature, but there is still a little bit of that. It doesn't come for free. Okay, there's still some work to be done. That you could do it cheaper than my crude example. Certainly, as I've described with the Italian example, which was the example where they never repaid anything. That is, they just kept on piling and piling for many years. The cost, becomes extremely high, to the surprise of that VP development in Denver. We know that if we defer features, their value decrease. That's the economic effect of, discount, the net present value over time. But unfortunately, technical debt, it just increases over time. Okay, that's the opposite effect. So, over the last 2 or 3 years, I've taken some interest on the concept of technical debt. Mostly because I'm interested in trying to put some value on architecture. What is the value of the yellow stuff? So that when we have a combination of yellow stuff and green stuff in our backlog, we can actually compare them. Well, maybe we need to bring this earlier in the development cycle, not just looking at dependencies, but maybe trying to derive some value to the architectural features from the value of the green stuff that it supports. So, trying different heuristics and different little techniques involving some fancy spreadsheet and little program to try to find, what is the value of architecture so that we can have a relatively uniform reasoning. So that's how I got into looking at technical debt. So are there advances on technical debt? Until about 2 years ago, there was no deliberate effort of research on technical debt. There was just people using the concept in their practice as consultant, people using the concept inside their organization. So there was an increased awareness of the concept. So what we wanted to do, a few teams around the world, is try to see if we could have a better grasp of the concept of technical debt. That is, go and look into many organizations, what form does it take, what people do about it, how do they reason about it, what attributes or property it does have, rather than just replicating in various forms and languages the sayings of Ward Cunningham and Steve McConnell. If we have a good taxonomy of technical debt, maybe this can lead to a better detection of technical debt, having some more systematic way of detecting it, analyzing it, something a bit less crude than the Israel GATT approach. Then trying to understand better, beyond just the folklore of our community, what are the causes of technical debt? What brings organization to accumulate technical debt? Because if we can better understand the cause and go to the why and the why of the why and the why of the why of the why, maybe we can improve prevention, give people guidelines on what to do and what not to do. So this hopefully could lead to some project management strategy, some practices, some rule of thumb, some guidelines on how to detect technical debt or prevent technical debt. Now, this is not going that fast. There is nothing earth-breaking that I can reveal to you today. There's a certain number of tools and methods that deal with Steve McConnell type 1 technical debt. All the small imperfections that are unintentional and scattered all around the code. And there's been quite some progress. There's many tools and many people doing all kind of interesting work to find code clones, which is one of the things, you find a piece of code and you do cut paste in that new piece of code and you change a few variables and then you expand things rather than trying to find what is the common abstraction and then use it in two places. So there's tools to do that. It's close to the code and we know nowadays how to analyze code and do all kind of fancy stuff with it and classify it and point to the users or the developers, you've done this and maybe you fix that, and this can drive some relatively easy and straightforward refactoring. Wow. They're not always necessarily that easy, but they're very often pretty straightforward. So there's a lot of things that tackle the McConnell type 1. The McConnell type 2, they're very difficult to detect by tools. If you've decided to do a flat file and added stuff in your flat file as opposed to putting extra table in the database, no tool is going to tell you that. Another example of strange technical debt, there's this nice little company, they developed a web-based tool, and they're a Canadian company, and they decide to, because they're running out of time and they really want to make it on the market, to let's not do the French thing, okay? We are a Vancouver company, we're very far from New Brunswick and Quebec. We'll do it, but let's just do the English thing. And they do the English thing and they're successful, but immediately their customer says, you know what, we have customers in Quebec, we need to do the French thing and we need to have it, okay, 2 weeks from now. So they say, 2 weeks. Let's just do the if then else. Let's find a francophone around here in Vancouver and we'll to translate the strings and we'll just do if then else all over the place. And they barely made it, they have 600 or 700 places where they have some if then else or some case or something. And I said, okay, wait. And now they have this fantastic thing, they're very successful, and they have this multilingual blah blah schmoldude that does two things in 2 languages. And then their salespeople find that there are people interested in their software in Japan, and on top of that, he told the Japanese people, no problem, our thing is multilingual, we'll internationalize it in no time. And he comes back to Vancouver and says, let's find a Japanese person to translate all the text, and can we have a Japanese version next week? What? So that's the kind of thing, the fact that you haven't used the proper package to do the externalization of all the strings and all that. No tool is going to detect that in your code. Okay, we can dive into at least 2 things. There was some research done on what people have called value-based software engineering and other fancy names. Real options and dependency structured matrix. So here in Vancouver and with some people on the east coast of the US, they've looked at technical debt. Erin Lim, the lady I was mentioning earlier, she's been interviewing various companies here in Vancouver and some further remote on the phone. And she tried to find out, if companies are suffering from technical debt, how they call it. So she doesn't say, you have technical debt, but she was describing some symptoms and trying to find how it's called, what form it takes, and then some demographic information about the size of the project, the length of the project, the duration, the domain, and things like that. she was trying to understand, you know, how people express their value if they do something like that. Is it an economic value? How visible it is in the organization? Is it a dark secret held only by a few developers or the whole development organization? Or it's very, very well known at the level of the company and the trade-offs that there exist. And trying to understand the environment. So there's different kind of technical debt, and the purpose here was to try to get maybe a better taxonomy than Steve McConnell, but actually he didn't get to a better taxonomy. Steve McConnell had pretty much nailed it right. We didn't find anything significantly different there. So there is a lot of things at the code level which basically is covered by the concept of code smell plus a few other things. And there are certain things at the architectural level which is McConnell type 2. Then depending on who you speak to, there is testing debt which was one big component to add to the pile when Israel got, and the other Qatar consortium people were trying to put a dollar value. And then it can spread to all kind of things. What are the things that you should have done and you haven't done right? You know, I overheard Gerard speaking about organizational, a new one that I hadn't heard of, but yeah, there's other things. Documentation debt, somebody mentioned to me requirements debt, and I didn't quite understand what they meant by requirement debt. But so I'm a bit puzzled by the other one. The concept can be certainly generalized to other things that have not been done right and could have been done right, and because they haven't been done right, they're slowing you down. But I'm going to stick myself to purely what, you know, code and architecture level, because I don't quite understand the other ones. And they would be even harder to evaluate in terms of impact. Certainly, things take different shape in different type of systems. There's more technical debt if you're dealing with a very large system, although I've seen a small system running extremely rapidly into technical debt. If they run rapidly into technical debt, they are a good case for actually a complete restart. You know, if you do something and you've accumulated technical debt over 6 months and you're successful, maybe now that you're successful, just restart the project. But if you have, you know, accumulated a lot of code in the kind of organization you've been working on, yeah, you're not even that big. There's very little technical debt in in safety critical software code, because the process and the constraints and all that do not allow you to accumulate technical debt too much in this kind of systems. So when you look at systems in avionics and medical instrumentation and that kind and transportation, there is a little bit of technical debt, but not that much. So the age of the system and the size of the system seems to play a role in increasing technical debt. This tends to decrease it. Do you have more technical debt or less if your team is distributed or not? I don't have enough data to judge that. It seems that it doesn't affect it that much. But technical debt, certainly, we need to put it in perspective by looking at the kind of domain. You know, we cannot generalize what we know about technical debt to any software development, as many people unfortunately do. Software development covers a wide range, a wide spectrum of type of systems. So there's really the two approaches, two families of approaches, for things that are the code level, you know, McConnell type 1, and things that are more structural. So at the code level, there's a lot of research happening in the last 3-4 years. It's a little bit of the effect of, you know, under the lamppost effect. You know, why are you doing research on this topic? Because I can, because we have the tools to do the research. So there's more and more tools that do static code analysis and also analyze histories in CVS and subversion and all that kind of thing to derive things, and combining information from the code and from the history of the code and from defects give you some hints that can be packaged nicely and point to developers to places where there is technical debt and what to fix. So basically guide the refactorings. Lately, there's been a lot of things about code replication and clones. So here the approach is, use the appropriate static analysis tool and refactor. And then we'll see a bit later when you refactor. Maybe you want to do that at very regular interval. Don't let it accumulate or think that, let's go to the release and then we'll refactor in one big shot later. Just refactor, even have some buffer in your development. Leave some buffer for refactoring. Curiously, what we found is that there are organizations, and we found that mostly in Europe so far, where the term technical debt was not used inside the organization, but they focused on something that they called maintainability. And at the beginning, I didn't quite realize, but when I was looking at what is it that you're doing, they were doing exactly the same thing. That is, they were looking at all the imperfection of the code. So the strategy here exemplified by two companies. One is Cast Software, where their headquarters in Texas, and SIG, Software Improvement Group, their headquarters in Amsterdam. They have a palette of tools, and they have customers, usually big customers that have the billion lines of code, including COBOL and Fortran and all kind of things. And they analyze this body of code, but they define a level of maintainability. So they have index of maintainability. And what they're looking at, in the case of SIG, their customer, they analyze the code of their customer every week. And they can see if the maintainability index evolves. And when it decreases, then they have these tools that allow the developers to drill down and find what is it that we've done over the last week that has decreased the maintainability. But also this index is not some kind of absolute things. They are benchmarked against other software in the same category, including their own competitors. So it's an interesting index. Basically at 6, you end up in a scale of 1 to 5, and the highly maintainable ones are sort of the 1 and 2. You can get the gold standard of maintainability. But this evolves over time because you're constantly resetting your index against the whole population of the SIG customer. So that was a surprise to me. That at SIG, until last year, until we discussed and I made a presentation to the company, they were not even using the term technical debt. The term technical debt doesn't appear on their website. They're only focused on maintainability, short-term and long-term maintainability. But it seems that it's exactly the same thing.
How do they measure that?
I'm sorry?
How do they measure the maintainability?
Oh, they have static analyzers that look at the code and look at the structure of the code and look at and they extract some metadata about the code, and they have some magic internal trade secret recipe to end up with this.
Type 1, right? Basically,
it's mostly type 1. They cannot do much about type 2. They cannot tell you should have a database instead of a flat file. That requires some human being. They do a little bit of type 2 in the sense that they can find some strange additional dependencies between components. And I'll give you an example of why this comes a little bit later. So they sometimes can peak. Now, the problem, both Cast Software, where Bill Curtis is, and SIG, that's their business. I can't poke into their business. I don't know their algorithm. They don't disclose their algorithm, or maybe they would under non-disclosure agreement, but that's their business. They do that for a living. That at the architectural level, it's harder to detect with tools, and there's relatively little research there. So there's two paths that we can explore. One is real options. Real option is something that comes from the financial world, which basically is a way to evaluate how do I invest now based on what could happen and some probabilistic model. And people have tried over the last 10 years and multiple instances to try to use that as a tool to aid software development organization to make decisions, but it seems to have never crossed the chasm. And now I understand a little bit better why. So it would look like this. We are at this stage, and we could invest $2 million to get at this stage. And when we will be at this stage, there's 50% chance that the market loves it and we gain $4 million, or the market hates it and we only gain $1 million. So what is the net present value? The net present value is -2, what we would invest, plus 50% of 4 million, plus 50% of 1 million. The net present value today, before we start, is $500,000. But let's say, because we're sort of unsure, the future looks, fuzzy. Maybe we want to take some technical debt. What if we were to do a minimal system by investing only $1 million, so taking $1 million of technical debt if you want, and the market loves it. If the market loves it, then we repay that debt, that is, we add the second million and we make 4. The market hits it, and we just stop. Well, the net present value today, the net present value is $1 million. Hey, this looks like investment. This doesn't look like technical debt. Actually, when I made this presentation some 6-7 months ago, in the audience there was a very wise gentleman called Steve McConnell sort of saying, well, your numbers do not look right. Why are you taking some technical debt? In order to increase the fact that you want the market to love it. You want to be there earlier, so your probability is probably higher, and you forget about the interest, Philippe. You cannot just add now another $1 million. You have to add more. You have to repay your interest. You've done some ugly stuff there. Okay, so I say, okay, I'll change the numbers. 1.5 here. Well, I still win. It's still more valuable than doing all the right thing and coming maybe later on that market to discover that we have 50% chance of not making it. That's where also, by putting this other viewpoint on the metaphor, we see that we can drop things here. We don't have to reimburse that ever. We just stop it. We walk away from it. We leave our debt behind. So we take the debt here by not putting $2 million. We repay the debt. Now, sure, the total development cost has been $2.5 million, not $2 million. But we only incur this in the case we have success. Okay, and I even put up pretty significant interest. So here we still have, a net present value on day one before even starting that is double of what it would be if we were just doing just the right thing. So, real option presented on a stupid little example like that looks very interesting. Well, not so much actually. First, there's many choices. We could say, well, we can do this, and then we have probability that it's favorable and probability that it's unfavorable. Here we don't do much. But what do we do here? Do we refactor, or do we just add some more feature? And here, what do we do? Do we add some more feature? Do we refactor? What's the probability? Very rapidly, there's not just one choice to make. There's multiple choices to make at every point in time. How are we going to allocate the probabilities to things? So when we start looking at concrete example, and we're doing this with my friend of the SEI, with Siemens, rapidly, after 2 hours of trying to scratch our heads, the probabilities becomes completely random. You just say, okay, there's 2 branches, let's do 50-50. Why 50-50 and not 90-10? We had no clue. It's rapidly, it's beyond, the number of choices is so big that it's beyond, usefulness. And so, we had all kind of, well, what if we do some Monte Carlo thing? Let's just, play the thing 1 billion times and see how it didn't end up to something really that useful.
Sounds like you need deep thought. You need deep thought from Big Blue to calculate this. for you.
Yeah.
It
So
sounds like a chess-playing
it's one of
algorithm.
the things where it looks nice on simple example on paper, but it doesn't scale up to anything that's useful.
I think the value of it comes not from the actual calculations of the numbers, but to
How
see
the
the
discussion.
effect that these different strategies have.
Yeah.
And what you're really illustrating here is deferring investment to the last responsible moment,
Yeah.
which is one of the core lean principles, right?
Mm-hmm.
So by spending some of that money later and only spending it in some percentage of the circumstances instead of 100%, you can actually afford to pay more and still come out ahead.
So he's stealing words out of my mouth. What we found, the real value is not doing the numbers and having the magic wand that tells you what to do. It's exposing these choices and their consequences, and the discussion in the room became far more important in building a shared mental model as to how do we look at the problem from a different perspective. So I would not dismiss completely real option, but don't expect let's pull up the tool and put the number in the tool and boom, the tool will tell you what the strategy is. It's just a way to sort of show that it's more than that. It's investment and it has different outcomes, and you can do it in a relatively moderate thing where you don't take too much risk, because in no cases the net present value was negative.
And the other value I see in this is that it introduces a set of terminology that technical people are capable of learning and having interest in because it's quite technical, but which is a shared vocabulary with business people because it's about money and
Yeah.
business. Because that's one of the big problems we have in communicating technical debt is how do you turn smelly code into dollars and cents impact on your business. In fact, in general, we have a real hard time as technical people communicating with the business people the consequences of different strategies, and this is a very nice way of exposing that.
So, I don't know, more work needs to happen there. Maybe it can be just transformed in nice explanation, but don't expect the magic tool done by Kruchten Engineering where you just plug your numbers and voila, it tells you this is the right path. Yes, go and take technical debt. Mostly because we found there's too much guesswork involved to trust any result. You can crunch the numbers, that's easy, but what do the numbers really mean is what's difficult. Another approach is using design structured matrix, also known as dependency structured matrix, and a little complement called domain mapping matrix. Here, tools to create them and manipulate them already exist, but there's probably more research that may be done on how to exploit them. So what is a dependency matrix? When you have chunks, components, large modules, subsystems, they depend on each other. So here I depict three, and there is a dependency of B on A and on C on B. So the simplest form, they may look like this. You may have some elements, and this is taken from precisely this Siemens system that we were playing with. And you can just say, yes, there is a dependency. So you put a cross or a 1 and a 0 if there is no dependency. And the matrices look like this. Actually, just putting a 0 and a 1, it's not that useful. It may be useful at the level of a compilation system to know what needs to be recompiled or inspected if you use that as a way to drive your code reviews. But we can also say, well, the dependency may be more or less. There may be a very tiny dependency, or this module depends a lot on this other module or component or whatever. So we may have something else than just a 0 or 1. We can have anything between 0 and 1 or some other scale. And then, because it's matrices, you can reorganize them, and you can reorganize them, and you can see that there may be clusters of things that are high, that have a higher coupling. There may be your big subsystem and things that are lower coupling. And there's already quite a few things that you can detect. If you have a lot of coupling, or if you have certain subsystem, and then you may have some parasite dependencies. It detects also cyclical dependencies. If you have some of them, they may not be cyclical at the compilation level, it's still perfectly compiled, but there may be dependencies due to callbacks and other subscription mechanisms. So what kind of dependency? Dependencies between stories and the supporting architectural element, dependencies between architectural elements. This is what people have been doing most of the time. And maybe also dependencies between stories. So you can play with all three aspects. And then to support technical debt, there is an interesting concept that was introduced by two people at the MIT, Alan McCormack and Carlis Baldwin, who have produced books and papers on modularity and the power of modularity, I think is the name of the book of Mrs. Baldwin. They looked at the density of the transitive closure of a dependency structure matrix. That is, you apply the dependency to itself n time, n minus 1 time if the dimension of the matrix is n, to find the dependency and the dependency on the dependency and so on. And then you look at the density. That is, you look at how many non-zero cells you have. So that's what they had called the propagation cost. So we took the concept of propagation cost and looked at exploring this path that I had in my real option thing. You know, there's what if we were to optimize early deliveries of feature and later implementation of good infrastructure stuff, or maybe we do the infrastructure stuff earlier and the feature later. We're trying to push the propagation cost a little bit further. The original definition by McCormack and Baldwin was a little bit crude. So we're also looking at using levels of dependency, not just dependent, not dependent, not just that binary 1, 0 or yes, no, and looking at the size of the component. You may have some big component depending a little bit on a small component or vice versa. The propagation cost of effort may be very different. We're not there yet. The problem is that, like the real option thing, it's easy to show the value on some simple example with 7 modules, but it's very hard to validate the idea on concrete system, especially large system, because people are not going to develop it in 16 different times just to provide you data on how to do it. So it's a little bit like in medicine. You may have a new idea of a treatment, but you're not going to kill 50 people to validate your treatment. To illustrate that, there is this system. It's a family of simulators for critical infrastructure and how they interact between each other. By critical infrastructure, I'm speaking about the power grid, BC Hydro, and the transportation grid, and the telecommunication grid, and the water system, and all these kind of things. And there are different simulators for two things, and these simulators, the government has given funding to various research organizations across North America to sort of see how we can build model in case of disasters. What would happen if we have an earthquake of magnitude 8 in Vancouver? So that's the thing. So it's not a trivial system. It's a system made of various pieces of software that have evolved over 10 years, and there's a lot of code developed by different organizations. So it's one of those ugly, complicated systems. But fortunately, it's all code that we can get access to, and we get access to the various development organizations. So getting access to the data is not an issue. So you can do two things, for instance. We didn't explore all the possible development paths, but we look at development paths that try to maximize value to the end user by bringing features incrementally, release after release early, and another path which is to minimize implementation cost. which was by minimizing rework and doing some of the yellow stuff early as opposed to maximizing the green stuff. So just to take two paths here, here value is being delivered incrementally on the path one. Here you see there's zero value in the first iteration and it only start there. The total value delivered is the same. No surprise. At the end, when everything was done, you had the same complete value. All the features were there. But the cost, and using the concept of propagation cost, the cost is different. There is about 14% more cost in doing this thing. And this 14% is due to the rework and the propagation of the impact of doing rework in some components onto the other components. So this approach seems to be a little bit more promising in terms of giving you concrete hard data to judge. Probably also because there are hypotheses, doing some Monte Carlo stuff to sort of see what's the sensitivity to the technique and to the numbers that you give as inputs will be necessary. But there is probably it's looked more promising. So there's some different values. So dependency structured matrix, not fully explored yet. There's quite a few people exploring them. There was a conference in Boston just a couple of weeks ago around this stuff. There are tools that produce or manipulate DSM. Probably the better known tool is from Lattice. So this tool will basically look at your code base and extract the dependencies matrices, and then you can refine them, populate them, put other numbers, and do other manipulation with them. It's not open source from SourceForge. Unfortunately, it's a tool you have to buy. Technical debt. Remember, it's only a metaphor. Actually, I wanted to invite Ward Cunningham to speak at a workshop on technical debt I'm organizing next year, and said, you know what? It's just a metaphor. I still stick with what I wrote in '92, and don't ask me to elucubrate on kind of other fantastic thing there. Maybe I'm not the right guy to speak about technical debt. I was just giving our community a nice little metaphor. Don't push it too hard. If you try to exploit it too hard, it'll break. Very interesting book to read, the book by Lakoff and Johnson, Metaphors We Live By. It's not a book about software, it's a book about metaphor and how we exploit metaphors in various avenues of life. So where the metaphor breaks, technical debt doesn't have to be repaid. Technical debt has a large part of subjectivity. It doesn't mean anything to be debt-free. We don't know what debt-free is in software because different people may have different perspective of what constitutes technical debt, especially at the McConnell type 1, it has maybe unduly, and Gérard emphasized some of that, too negative connotation. I hope that the re-adoption example gave you a feel that maybe it's good investment. Maybe you don't need to invest and do all the yellow stuff perfect too early. It may increase the value of a project for a time. It may allow you to go for a whole year or more, but then you have to realize and remind people that help you or convince you to take the technical debt to repay it. That's where we see organization being a little bit perverse, Sure, we discussed, oh, we could do this and we could do that and we could shorten the development time, and the product manager and the business analyst and whoever represent the customers, oh yes, let's do that, yes, thank you, Mr. Developer. But then, a year and a half later, they're there, and they, what, technical debt? What was that thing? Did we agree for you to do ugly stuff and suboptimal design? No, you did it to us, well, now you live with it. You know, come on, you're going now to ask me to. There's also a contractual situation that makes it. You know, if you write code for the BC Ministry of Health, you know, you accumulate technical debt. Maybe you don't care, so it may be part of the game. You know, let's accumulate technical debt. Then you know it's a captive market that have to come back to you, and you say, oh, adding this feature is going to cost you an arm and a leg. So it may even be, you know, in a perverse way, part of the strategy. You know? We know that we're taking technical debt. We just don't call it like that. We sort of say we are a very fast, optimized organization that can deliver to you solution in very, very short time. But what we mean is that we are going to take all kind of shortcuts internally to get this first contract, because after that, you're bound to us for the next 5 years, and we can recover our technical debt from you, the customer. So, technical debt may be seen as an investment. Yeah, it breaks in various ways. So what can you do? Going back to the study of Erin Lim and two ladies in Baltimore who also interviewed many organizations about technical debt, they came up with some clustering of this organization. And this classification is mine, so don't blame it on Erin. This is Caroline Seaman. I read what they wrote, but I made this classification myself. So there are organizations that had never heard the term. They actually didn't know that they were suffering from that. For a few, it was a ha-ha moment. Oh, wow, this was very interesting what you told us there. Did you have more for us to read? And they had never heard of the concept. There are organizations where everybody knows about it, but nobody wants to speak about it. It's a secret. There are organizations that have gone some way down the path of what Israel God says, trying to put numbers on it. Very few. They're the ones who are aware of technical debt, and they read the blogs and they attend the webinars and things like that. As I said, I found quite a few organizations in Europe that went to the 5-star ranking. And then there's, I would say, educated agilistas that know about that and try to do very systematic debt reduction. And then there's the more naive agilistas that sort of say, technical debt doesn't exist, we are an agile team, we don't go into technical debt, you know. So, ignorance is bliss. This organization, they had technical debt. They could see their productivity reduced, but they didn't know why. And actually, us going into them and interview them made them aware of it. Elephant in the room, many people knew about technical debt, but they don't feel like it's their concern. You know, they keep hoping that someday they'll come to work and the elephant would have gone. So it's, yeah, you know, I'm an educated software developer. I know about technical debt. I read blogs and I attend conferences and things like that. I know that we have some in our organization, but who am I to say anything about it, you know? We found that when the organization is broken in relatively small silos that do not speak much to each other, where the decisions are sort of scattered in those silos, where nobody has a complete product mentality, you know, we're all in that same boat, you know, across the whole organization, and it's not like, oh, technical debt, it's their problem, we don't want to actually have any visibility of it. Or sometimes where there's very short-term focus. And this was a little bit more prevalent in IT organization inside an organization, as opposed to company who sold software-intensive product or just pure software. The big scary number, that's the ones who are trying to put some numbers on it and going to some extent, maybe not always the whole extent, to where Israel Gap is describing. CAS software and SIG, sorry, you don't have Bill Curtis, but that was my slide from the day before yesterday. CAS software has some stuff there. It seemed that ThoughtWorks with the where Martin Fowler and Jim Highsmith are. They're also trying to get some systematic consulting focused on technical debt, both analyzing it, looking at its root causes, but also remediation of technical debt at different levels. So, issues. Well, these things about the big scary number, it fits the metaphor. Yeah, we speak about technical debt in terms of, oh, you are in debt of so many thousands or millions of dollars. But as I said earlier, what do you count into that pile? What tools you use may affect it, and the cost to fix. You have to be much more selective as to how much of that debt you want to reimburse. Maybe you can just leave, the bulk of it. You don't need to care about the whole thing. And this is where the fact that, organizations like CAST and ThoughtWorks, something like that, that's their business. They want to sell you consulting. They want you to fix the whole thing, So their idea is to maximize their pile, not necessarily focus on where there is high leverage from your perspective. So I see that as a bit of almost a conflict of interest. You ask a person to sort of say, tell me how much I am in debt, and you are the same person, that get me out of that debt. That person is not going to tell you you have zero, and you obviously don't need my services. Okay, so it's their best interest to make the thing look pretty ugly. So the 5-star renting, that's what I was describing, the kind of thing that SIG is doing, and also CAST software. Constant debt reduction, that's what the more mature, modern organizations that do iterative development in various agile or less agile form do. They make the technical debt a visible item on the backlog. That's why that was the purpose of my presentation last year or 2 years ago at this conference on the 4 colors. Make the black stuff visible. While the other message is make the yellow stuff visible, but make the black stuff visible. Put your technical debt visible. Make it also visible outside of the development organization. Don't do like the elephant in the room or the ignorance is bliss category. Make it visible at the level of the organization. We have decided at this point in time to take this technical debt. It has a value, it has a cost to repay, and it needs to be scheduled like the rest of the thing that we schedule and plan based on a global reasoning. You cannot just make it disappear. A lot of the technical debt, certainly the technical debt of micronal type 1, do reduction very regularly. Don't wait until it accumulates in large chunks, because then you sort of say, wow, this is too massive to undertake. Some organizations have really some buffers in their development cycle to do that. Some organizations told us the best is to lie. We keep some buffer, but we don't show it. We just have more cost there, but we know what we're using it internally. Why? Because they cannot actually express very well to the rest of their environment what
By
that
buffer, you mean buffer for black stuff?
Yeah. So if this is your time box for a release, you do the work here. That's some buffer to absorb some of the uncertainty of your estimate. That may be some defect correction, because you'll inject some defects, and maybe you have an extra buffer just for this debt reduction, if you want, debt repayment. And your buffer doesn't need to be uniform. Let's say you had a release here, maybe your first sprint or your first iteration, you have a much bigger buffer, and then you have smaller ones as you get closer to the next release. And then the 6th category was of companies is we are agile, so we are completely immune to that. And that's when you take some of this motto, which by the way, they all have some validity when you take them to some extreme, Defer decision to the last responsible moment, yeah, but when is the last responsible moment? If the last responsible moment was 3 months ago, there's maybe no point in deferring further. You ain't gonna need it, yeah, but if you really needed it, then maybe now it's technical debt, and maybe you need to repay it now rather than pushing that too much. We'll refactor this is fine, but we'll refactor this later. Maybe you want to put a date on the later, not later as in going to infinity. To deliver value early, sometimes you need to articulate value for whom. Maybe not value for the end user, maybe not value to have something demoable for the business analyst or the people living in the other floor. Maybe it's value for other stakeholders in the organization, and maybe at the beginning you need to build this walking skeleton that Alistair Coburn does, so that maybe in the early iteration you do some significant amount of architectural work with not much visible, not much green stuff. So I showed you this one. This is a cycle that you may get into it very, very rapidly. If you constantly are under pressure and never repay it, you may accumulate technical debt very rapidly, which is what that big team did. In 4.5 months, I arrived after 6 months in the project. They had accumulated an enormous amount of technical debt extremely rapidly. They were trying to repay some of it, but not necessarily the big architectural stuff, because it was too hard to shove from below. Going back to some of Jim Highsmith's stuff on technical debt, looking at value, the value is in that extrinsic quality, the quality that is visible from the outside. And Jim suggests that the net present value that I was describing, the real option, could be a good measure of it. But then there is the intrinsic quality, where the metric is technical debt. And then there is the constraints, where the metrics are the cost. So this is iron triangle revisited, where value is the net present value, projecting the future with maybe different paths and different probabilities of occurrences and different investment that you may have to make. Intrinsic quality, looking at the code and the structure of the code, so some measure of technical debt, maybe not in this crude measure that Israel Gatt was suggesting, and then the cost. And he looked at it, how it evolves over time. Maybe this is a little bit too complicated to go through now. One thing that I've noted, because I've been working on relatively large systems in telecommunication and aerospace, there are certain type of defects called multiple component defect. Those defects that require fixes in multiple components, they're not very localized. And they represent on large systems somehow a small fraction of the defects. Most defects, fortunately, they're relatively well localized. But they require to fix 20 times more modification and on average 50% more effort than the other one, the 95% others. And they're very often very hard to fix in one shot. There's some partial fix and then some further fix that they tend to not be very well localized in time nor in the modules. They're more localized in modules. 20% of components are hit by 80% of these multiple component defects. So in large system development that are long-lived, a lot of the technical debt is accumulated by not being able to do complete systematic fixes for these multiple component defects, especially in large organizations that have different teams or sometimes different companies or organizations responsible for the various components. the changes are relatively hard to coordinate. So you may be under good control of one or two components, but since you have no control and you cannot have a matching bug fix from some other organization, then you do some complicated fix with some kludge and workaround, and then the other organization, the next release, fixes it, and you have to undo the kludge. And a lot of the technical debt in this large, long-lived system that have 15 years old, million lines of code, are of that nature. So the system may have been very neat and clean at some point in time, but there are some organizational issues and structural issues that make them look like that. So technical debt sometimes appear in that form, this multiple component defect. Finally, when we look at what are the root causes, why are you in technical debt? What caused it? It may be something that starts to pop up on my radar more and more often, cognitive biases and sometimes reasoning fallacies. Escalation of commitment. Sometimes people run into technical escalation of commitment. Basically, you've made some choices, and then you try to make choices that reinforce the choices that you've made before, even in the presence of evidence that the initial choices was not the right one. And one perverse form of it is the so-called sunk cost fallacy, which is, people call it sometimes throwing good money after bad. Since we've taken that path, we're going to make other design decisions that reinforce or try to consolidate that path because we don't want to throw away what we've done. Whereas maybe the best strategy at some point in time is just to sort of say, let's not do that, let's undo it and do the right thing now. It's just basically putting some, solidifying the wrong thing that we've done in the past because we feel that it was some kind of an investment that we cannot throw away. Other things is anchoring. Anchoring, maybe one way to describe it is, the attitude that many software developers and architects have of, when I have a hammer, everything looks like a nail. I'm your JBoss expert, and I vaguely hear your problem, but I know that JBoss is already the solution, and I'm already trying to design what you're telling me using JBoss or whatever. And I'm in love with JavaScript and CoffeeScript, and I'm not really listening, but I already know that this is the solution. And confirmatory bias seems to also play a role. People tend to filter when there's new information flowing. You tend to pay attention to the elements of information that reinforce your own thinking, but the one that may invalidate your own thinking, you're not even paying attention, you just drop them. And I'm not saying you're not doing this perversely, consciously. Two things are unconscious. They're biases, they're not necessarily political games. Now, people may play political games, deliberately, consciously, but a lot of the biases happen intuitively. They're triggered by the bottom of our brain there. Is it called the limbic system? I forgot. So when we were trying to look at, upstream what caused technical debt or the fact that you decided not to repay technical debt or that kind of thing, that's the kind of thing that we hit, these cognitive biases. In some cases, not all of them. Again, maybe we need some more work. The kind of tools that you may want to look at to help you with technical debt. Some of them are named there. Again, the slides are here. So, what we found is that informing, describing technical debt is already quite a good step. When people have the concept to be able to speak about it in a larger group than just the software development group, and identify that, name it, pretty much the kind of thing you do. Identify the user story and find a good name for it and a short description and classify it. Is it at the level of the code? and its quality? Is it more structural? Assign it a value and a cost, both immediate and future. Make it visible, put it in your backlog. My son, who's a software developer in Montreal, he has instrumented Track, the open source tool that they use, to actually represent the 4 colors of the backlog, except he had to use something else than black because that was not very legible. And prioritize your technical debt, with other elements in your backlog, as opposed to backlog that I've seen that have only the green stuff, and the yellow stuff is in the head of a few architects, and the red stuff, the defects are in a defect database, and the technical debt, it's nowhere to be seen. If you make all things visible at the same place. A little game, that was finally the URL I was looking for. I couldn't find it. I knew I had it in this slide deck. So remember, technical debt is not a defect. Where I've seen discussion completely diverge is when people were lumping the defect on the customer defect database with technical debt. And say, oh yeah, we need to fix these defects. Well, you're not necessarily fixing the technical debt. It may not be in that database. Suitable system architecture is not likely to spontaneously emerge out of weekly refactorings. It may, but you have to have somebody who drives it, and you need to be aware of how much of an architecture you have or how much of an architecture you need. And maybe some novel project, they need also an architecture owner. Not an architect or an architecture team that's disconnected from the thing, but somebody in the team who's sort of driving architectural issues, making them visible, making people aware that some choices have to occur. So, you have product owners and Scrum Master in Scrum teams. Maybe you should envisage having, in some cases, an architecture owner. Okay, summary, technical debt. It's more a rhetorical concept or category than a technical or ontological category. It's not a technical or scientific thing that we can neatly isolate and study. It seems to be more a vehicle for having a conversation. It resonates well with the development community and sometimes also with the management community, providing you don't make the mistake to try to push the metaphor to its extreme. So it may bridge the gap between the business decision makers and the technical implementers. But it's only a metaphor, and don't push it too far. Upcoming events, there will be a special issue, the IEEE Software Magazine on technical debt. And I will be trying to organize a 3rd workshop on technical debt, this time in Europe, in Zurich next year. When you download the slide, there's quite a few references on learning things about technical debt, including other people who made talks, which I copied or reused. And that was about it. Sorry I lasted a bit too long. It's the first time I tried to do the game like I did, so but okay. Let me know what you think about the game. I don't know, do we have evaluation sheets for the tutorial?
No, we don't for tutorials.
Oh, okay. You can always send me an email if you want. I'll appreciate your feedback. I've done this in various lengths, from 15 minutes to 1 hour. I had 1 hour and 15 minutes in Seattle the day before yesterday to 3 hours. Thank you, Gérard,
Thank you,
for your